In this video we are gonna pay attention to Taylor series. We can approximate the function f of x using Taylor series by writing as f of x naught plus the derivative evaluated at x naught, x minus x naught, plus the second derivative evaluated at x naught over 2 factorial x minus x naught squared, plus the third derivative evaluated at x naught over 3 factorial x minus x naught to the power of 3, plus the nth order derivative evaluated at x naught over n factorial x minus x naught to the power of n. So I can expand my function f as a polynomial function around x naught. If I take x naught to be equal to 0, I get that f of x equals f of 0 plus f prime of 0 x plus f double prime of 0 over 2 factorial x squared plus f third order derivative evaluated at 0 over 3 factorial x cubed plus f nth order derivative evaluated at 0 over n factorial x to the power of n. So my Taylor series is the following as a summation form: f j order derivative x naught x minus x naught to the power of j over j factorial. That is Taylor series. And f of x equals the sum from j equals to 0 to infinity f j x naught is equal to 0 times x to the power of j over j factorial. This is the Maclaurin series. So from Taylor series we can go to Maclaurin series if we plug in x equals x naught equal to 0. That's a special case. If I expand my Taylor series around 0, I get the Maclaurin series. That's what it means. Applications. One application is the following. Let's take the Taylor series, f of x equals f of x naught plus f prime of x naught x minus x naught plus higher order terms. And let's drop the higher order terms and keep only these terms at the right hand side of my formula. At the right hand side I keep the function evaluated at x naught, the derivative times x minus x naught. That here is the equation of the tangent line. At x naught, f of x naught. So if I have my curve of the function, and let's call this point that's with coordinates x naught, f of x naught, I can draw the tangent line to this graph, and the slope of the line lambda is the f prime of x naught. So this is one important application. You can see that if you drop the higher order terms in the Taylor series, you can derive the equation of the tangent line from here. Now let's see how to calculate. Let's calculate the Taylor expansion of the exponential around x equal x naught equals 1. So I have to calculate the derivatives. That's the simplest function. The exponential, when I differentiate it, I get the exponential back. And the nth derivative is e to the power of x. Now I evaluated the function and the derivatives at x naught. Okay, now I go and I write my Taylor series. F of x equals f of x naught plus f prime of x naught x minus x naught plus f double prime of x naught x minus x naught to the power of 2 over 2 factorial plus f third derivative evaluated at x naught x minus x naught to the power of 3 over 3 factorial plus f nth order derivative at x naught over n factorial x minus x naught to the power of n. So that's e plus e x minus 1 plus e over 2 factorial x minus 1 squared plus third derivative, which is e x minus x minus 1 to the power of 3 over 3 factorial plus e x minus 1 to the power of n over n factorial. Now I can take a common factor e, so I have f of x equals e 1 plus x minus 1 plus x minus 1 squared over 2 factorial plus x minus 1 cubed over 3 factorial plus x minus 1 to the power of n over n factorial, and that can be written as e times x plus x minus 1 squared over 2 factorial plus x minus 1 to the power of 3 over 3 factorial plus x minus 1 to the power of n over n factorial. And I can write that in the following way: ex plus e times brackets x minus 1 to the power of 2 over 2 factorial plus x minus 1 to the power of 3 over 3 factorial plus dot 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 x minus 1 to the power of n over n factorial. And that is e times x plus e times the sum from j equals 2 to n x minus 1 to the power of j over j factorial. So my function f of x equals e x plus e times the sum from j equals 2 to n x minus 1 to the power of j over j factorial. That's the truncated, or I can write it f of x equals e to e times x plus e times the sum from j equals 2 to infinity x minus 1 to the power of j over j factorial. And you can see that for x equals 1, f of 1 equals e. The more terms you get in the Taylor expansion, the better it is. The better is the approximating the function. So here I've used the exponential because it's a simpler function, and I use Taylor expansion around x not equal to 1. So I calculate the derivatives, I evaluate the function at this point, x naught, and then I just go back into the Taylor formula, and you see that I have e appearing because I evaluated at x naught, it gives me always e, and then I have x minus 1 to some powers, and then I take e as a common factor, and I just get rid of the ones here because they have opposite sign, and then I can write it in the truncated form, e times x plus e, the sum from j2 to n, x minus 1 j over j factorial. And I can include more terms, so I can write the first term and the remaining terms, which gives me a good approximation of the exponential. And consequently, if you want to get from Taylor to Maclaurin, you just this neighborhood x naught point is equal to 0. X naught equals 0, you get from Taylor to Maclaurin.